Thank you. Mulțumesc. Good morning to you all. Bună dimineața. I'm here to talk about magnetic locks. So I hope I can do this in 30 minutes. Let's see if this works. Fail. Backup plan. So I was here 6 years ago for DefCamp the last time, and this time I'm back also talking about physical security. Back then I did also a lockpicking workshop, but the topic for today is this lock and how I spent some time, actually quite a lot of time, in figuring out how this lock works and what kind of ways there are to defeat this lock. It's a lock originally Japanese from the firm Miwa, and it's also sold in the Netherlands, where I'm from, under the name Anker. And the reason I know about locks is that that's a hobby of mine. I'm actually a computer hacker in IT security, been there for 25 years, but I'm also really into lockpicking, also been doing that for over 25 years. I used to be president of a lockpick organization Tool, and shameless plug, I've been writing a book about lockpicking together with a few friends. It will be out in January at no starch. If you go there now, you get 25% off. The digital version is already available, that you get for free if you buy the hard copy, 460 pages of lockpicking goodness. But today I'm talking just about one specific lock. So why is this lock so interesting? If you open it up, you will see that there are pin stacks inside, which is pretty typical for a lock. So here in Romania you have a lot of these dimple locks, but the internals of those locks are the same. You have pins that ride on springs, and they need to be in the correct position for the lock to open. But there is also some stuff going on there on top, and that's what makes it interesting, because there are magnets in there. And if you look at the key, you will find that on one side of the key there is a bitting that resembles normal bitting on normal keys. That works the same way as any kind of lock. That would not be very interesting to talk about for half an hour. What's interesting is these 8 black blobs. And those blobs are either just black material, or they are magnets, cobalt samarium magnets. And they come in pairs, and each pair moves an element inside of the lock. And this was sold in the 80s. It was invented in the 80s as a high security system. So here again you see a opened up version with the pins that are quite normal. And then within the plug are these 4 sliders that go back and forth, and they are moved by the magnets in the key, and they need to be moved to the correct position. Now the pins, they work like any other pin, as I said before, and how that works is that the length of the pins needs to precisely match the cuts in the key, and when you insert the correct key, all the pins will be aligned so that the pins align at what's called a shear line, and that allows the plug to rotate. But there are also these sliders, and these move laterally, and there's a pin sticking out, and these need to be moved so also these sliders do not block the plug from rotating. And yeah, the talk is actually about successes and failures, because I'm a strong believer in doing a bit of research, and doing research you obviously fail a lot of times, and then in the end hopefully you also have successes. Many people just go on stage and tell about their eventual success, but they leave out all the failures that they had along the way. I had my share of failures along the way, but since I only have half an hour, I don't have time to talk too much about the failures, but I have a presentation elsewhere on the internet. I'll link at the end, where you can learn more about the failures. But this is my first success. My photoshopping skills, not perfect, I admit, but anyway. Here's a lock without a key, and you see that the pin is not at the shear line, so it won't open because of the pins. But also the yellow thing is the slider, and there's a magnet in the slider, and the slider is sticking into the housing of the lock, and also that will prevent it from rotating. With the correct key inserted, the pin is exactly at the shear line, so it's free here. And also the magnet in the key will operate with the magnet in the slider, pulling it away, also freeing it there. And if everything is free, you can rotate the lock. And if you take a key and you take a bit of magnetic paper, you can actually see that there are magnets inside. And if you look really closely, you see that the blobs, some blobs are whole blobs and some blobs are two blobs. And that has to do with the orientation of the magnets in the key, because there are several possibilities in how you put the magnet in there. I've taken out the plug, put in the incorrect key, and if I have the incorrect key, again you see that it will not turn because sliders are sticking out, pins are sticking out, it doesn't work. And with the correct key, obviously everything is perfectly aligned and it will open. Okay, so that's very short. I hope you're all still with me in how this thing works. So let's start by defeating it. And actually, what I left out of this presentation is that I started out with taking the original keys, and my plan was to take out the magnets and to put my own magnets in there to create a new key or to maybe copy a key, because these keys are hard to copy. You cannot just go to a store and make a copy. But all my metalworking skills were just failed. So I did a lot of work trying to get those keys and use a Dremel to take out the magnets. Everything failed. Actually, it failed so much that I completely abandoned the project until 2020, COVID, too much time on my hands, and I thought, well, you know what, let's buy a 3D printer. So I bought a 3D printer especially for this project, and I learned a little bit of ASCAD, and I came up with a model of the key. And of course you can just type in the code of the bitting, so you'll see a change. You can type in what kind of bitting you would like to have on the key. And of course the 3D printer cannot print magnets, but it will include little square holes in which you can put your own magnets. So I bought some cheap magnets. You see one on the top, it's a 2 by 2 by 2 millimeter magnet, and you can just plop them into the key in the correct position. And I tried it out on a cylinder and it worked. So that was actually the first hack, because if you talk about lock security or security in general, for a system to be secure, it really depends on what your risk model is. Sorry, I had to pose for the picture. It really depends on your risk model. So if you're afraid that somebody will, a burglar will get into your house, that's a completely different risk from the risk of you lend somebody your key and they secretly make a copy of the key. So that's a different risk. So it depends on your risk profile, what kind of protections you need. So one of the things you might be worried about is key copying. And here I've shown that key copying is possible. Actually, this is now really a big problem in the physical security world, because a lot of keys are quite easy to 3D print. Manufacturers are trying to improve their keys and putting on little movable elements in their keys, but there are ways around that. So I had this key printed, and I thought, this I didn't tell you. What I did was I bought an SLA printer using a resin, because I thought that this key had needed such good tolerances that I needed to have a SLA printer to do so. And I found out that these resin printed keys are very brittle. So if I would drop it here, it would break in two. It also depends on what kind of resin you're using, and I was not using the really tough resin, so that also played a part in it. But I thought about, how can I improve my key so it becomes more sturdy? And you can see one improvement already, because that key has not 8 holes, but 4 holes for the magnets. Because normally it's only, for the 4 sets of magnets, only one of them is used, and the other one in the key is a fake. So by leaving out those holes, the key becomes more sturdy. I then thought about using smaller magnets. So I bought some 1 by 1 by 1 millimeter magnets, but that was a total failure, because if you pick them up with your tweezers, they just flip around and they go everywhere, and it's horrible. So I forgot about the 1 millimeter magnets, but there was another optimization that actually a colleague of mine suggested, which is to use disc-shaped magnets. And now the thing is that the magnets in the key, I haven't told you yet, but they can face north up or north down or north to the left or north to the right. So there are 4 possibilities. And with the cubes, you can just turn them in the correct direction. But with the disks, it depends on whether north needs to face up or down or left and right, whether it's flat or on the side. But it's not really a problem because we're printing keys anyway. So if I know what kind of magnet needs to be in the key, I just can print the correct hole to put the magnet in there in the correct orientation. So that key will also work. And then the funny thing is that my wife was also a little bit infected by me working with a 3D printer, and she thought, that's interesting, 3D printing stuff. I want to do that as well, but I'll just buy my own printer, which is a I always forget the abbreviation, a filament printer. Anyway, the cheap printers that use PVC and stuff like that. And I tried to print a key on that printer, and that actually also worked. So the tolerances are good enough for this printer to also print a key that'll work. Right. So when you have temporary access to the key, it can be copied. You can measure the magnets, and for this you will need a special device, a magnetometer, a device that has a small magnetical sensor called a Hall sensor, and you can measure the magnetic field. Then you know where the magnets are and what the orientation is. You'll print a 3D key with the holes in, put the magnets in, and you have a duplicate. And actually the heights of the pins, normally it's very hard to see what the code of the key is. You need to really measure quite precisely, because it's really less than a millimeter difference is a different cut in the key. But with these keys, there's only 4 possible depths of the key. And I've seen so many of these keys that I can now, just with the naked eye, look at a key and tell you what the bitting code is, just because there's not much variation there. So this is already interesting. I can copy what is considered to be a high security key with a 3D printer. But let's take it a step further. What if we have a cylinder but we don't have any key at all? What can we do then? And now it's good to realize that the pictures I've shown you before showed you that there is a magnet in the key, but there's also a magnet in the slider that it operates. So there are magnets in the key and in the lock. And here you see the 4 different orientations that are possible: north up, north down, north left, north right. And it's always the same combination together. So here north is facing up, and then in the slider north needs to face right. So that's the only good way to get the slider to move in the correct way. So there is a one-on-one relation between the magnet in the key and the magnet in the lock. So if you read out the magnets in the key, you know exactly what to expect in the lock. But also vice versa. If you read out the magnets in the lock, you will know exactly what is in the key. And the sliders, 4 of them, they always move in the same direction in every lock that you will find, but 2 move to the right and 2 move to the left. But it's the same ones that go right and left in every lock. And it's denoted with the arrows there. So if I have the key with the magnets as shown there, then I know for sure that this is going to be in the lock. Because that's the only way where by inserting the key, the sliders are being sent to the correct position. But as I said, I can also read out the magnets from the lock and figure out what magnets are in the key. Now at first I built my own magnetometer to read out the magnets, and then I thought I can read them out in the cylinder. But the cylinder is quite, the entrance where the keyhole is quite small. So my sensor was too big. So I then had to spend a lot of time to create a new device. And here I went wild and bought some stuff from the internet to put on an Arduino. And I built my my magnetometer that also does all the translation automatically. So that's a very tiny sensor. This was actually the hardest of the whole project, to get that soldered onto the end of this little bit of flexible PCB. I can insert it into the cylinder, and you can see here whether it measures north or south. And you will also see marking, so I know which slider I am currently at. And the software in here will automatically, depending on the location, which slider you're detecting, it will translate from cylinder to key or vice versa. So by reading out the cylinder, it will tell me, well, this will be in the key if it operates. So I read out the cylinder, and if I now check on the key, I will find exactly what's there on the left. So that indeed is the key to this cylinder. So that's very interesting. This means that if you have such a cylinder on your door, I can just go to your door, use my little device, measure it, and I know already half of what your key looks like. I know the magnets. But we still have the pins, and that's an issue. So I could go to your cylinder, I could read out the magnets, but yeah, the pins, no idea. So there are several ways to tackle this. First of all, I said before, there's only 4 different heights per pin, and there's only 4 pins. So that means that for the pins, you only have in total 256 possibilities. Now, depending on your risk model, it might be worth to print 256 keys, and maybe every day you go with 1 key, you try it out until you got the key that works. Might be feasible. I also tried lockpicking. It can be done, but it's actually quite hard, harder than you would expect. So I don't think that's a really real-world attack. But then I thought about bumping. I don't know if you've heard of bumping. Bumping is a technique where you have a key that is cut to the deepest cut, and if you, with a lot of force, bang it into the cylinder, these teeth that are still present will touch the pins. They will get a smash. And what happens is actually Newton's law. You know those things with all the balls. One ball you let go, and then the one on the end flies away. Same here. You smash the pin here, and then the pin on top will go out of the way, leaving a small time frame in which you can open the lock. Now I thought, could this be done with this magnetic lock? So I created a key with the correct magnets, because I also need to think about the sliders, but the bitting is not correct. But I can use this as a bump key. So now it doesn't operate, but I smash on it with force and it opens. So that's an interesting attack. I have to say I cheated a little bit. I mean, here it looks very simple. At first go it was correct. But in reality, I mean, it takes maybe half a minute to get it to open. So this is actually a feasible attack. If you really want to get into somewhere and you don't want to break the lock, you could sneakily figure out the magnets, print a key, come back, and in a minute you're in. So that's already quite interesting. But what's also interesting is that these are cylinders that were sold, especially to large institutions, hospitals, government, in high security settings. Well, not so much anymore, because this is quite an old system. But in those facilities, they normally use master keying. So you have your own key for your own room, but then there's somebody who has the key that opens all the rooms, the master key. And that's, with this system, also quite interesting. So let's look at how master keying works. So you have individual cylinders for an individual lock, and you have a key that opens all of these doors. So let's look at a small subset. In a traditional lock, it would work like this. So Alice has a key with a certain cut. Those are numbered 3, 6, 2, 3, 5. And the mastered cylinder has pin stacks that are cut an additional time. So each pin can be in 2 different positions, and it will still open. So you can make 2 different keys that will open that cylinder. So as you can see, this cylinder will be opened by Alice's key because the shear line is free. And this is the cylinder of Andy, and this cylinder cannot be opened with the key of Alice. Now Andy also has a key that will work on his cylinder. And Andy's key will not work on Alice's cylinder. So they both have a key that opens their own cylinder. And you'll see that there is also the possibility to create a master key. This is the master key. And this master key opens both cylinders of Alice and Andy. And if you take a look at all these three keys, you will find that in most positions they are the same, but there are two positions where they differ. Now in a traditional master key system that uses these kinds of keys, it is always the case that the master key has more material on the key than the user keys. These are called user keys. And the reason is that you don't want Alice to be able to file away a little bit of material to get to the master key. So the master key will always have more metal here. So you cannot file metal on there. But that isn't true for the anchor. But let's look at how we could defeat this system. Suppose I'm Alice, I have my own key to my own cylinder, and what I can do is I can go to Andy's room. My key doesn't work, but what I'll do is I create new keys that are the same as my key, but they differ only in for the first pin. And I try out all different other combinations. And I just go to Andy's door and try them out. And maybe none of them will. Then I'm going to take again my own key, but now I'm going to change the second pin in all the positions. So the key is still my same key, but only the second pin differs. And I try those out on Andy's door. And maybe this time there's one key that will fit. And that gives me some information. So I now know that this depth is a depth that no, sorry, I'm talking about Andy's cylinder. Of course, I'm doing this in my own cylinder. Excuse me. So I'm trying in my own cylinder with my own key. These don't work, but there's one different key than mine that also works. So I know this must be part of the master key. And I can repeat the process for all bittings, positions, pin positions. And as you can see here on this position, there's also another cut that works on my cylinder. And now I know that what the master key is, because it needs to have these other positions that I found in my own cylinder. So this is something that's a vulnerability in master key systems anyway. So if you live in an apartment complex where you have master keys, you could try this with your own. Oh, out of battery? No. So you can try it on your own cylinder. And you will figure out what the master key is in your system. So master keying actually adds functionality at the cost of security. But in the lock I'm talking about, we also have the magnets. And the magnets can also be master keyed. So there is a magnet here or there, but there could be also two magnets on both sides. And that is used for master keying. So let me show you how this works. This is my key to my door. I know my key, I know the magnets on my key. So I know that these green magnets need to be in the cylinder, otherwise my key wouldn't work. But what I could, and I would like to figure out what the master key looks like. Now what I can also do is use my device to measure the magnets in the cylinder. Well, these green ones I know that are there. But if I measure, I might find some additional magnets. And those are there to facilitate master keying. Now, what does that tell me? Now, the master key needs to have magnets to operate all four of the sliders. And the middle two sliders, they only have one magnet. So I know for sure that the master key will have magnets to operate those sliders. Otherwise, the master key wouldn't work on my door. What else do we know? Well, these blue magnets are there for a reason. Something must be using them. It's the master key. So because I found this magnet that is not used by my key, it must be used by the master key. So I've learned, by decoding the magnets in the cylinder, that the master key will have the corresponding magnets in the key. What else do we know? Well, there's two magnets that we have on our key, but we don't know if they are on the master key. Should they be included or not? Well, I could talk very long about this, but let's use an example. You could figure that I have this key and cylinder, and my neighbor has this key and cylinder. And here you see that it could be possible that let's see that this one here is different than there. So the master key cannot have a magnet there because it would only operate on one of the two cylinders. So if I go to my neighbor's door, cylinder B, and I read out these cylinders, I learn again a little bit more information, and I now know that this cylinder magnet cannot be in the master key, because then it would only operate one cylinder. So that's what I've learned. The one bottom left, I have not learned any new information, so I'm still unsure if there should be a magnet there. And I've learned something new, because I found here a new magnet. And that could also be in a master key, but I'm not sure yet. So until I find some other cylinder where this would not work, I have more certainty. So I need to go to a lot of cylinders, and every time I read out a new cylinder, I gain additional information, and my master key will get better and better and better. The complicated thing is that the same is done with the pins. So you can also do master keying with the pins, just like regular locks. So the pins can have smaller pins in between to facilitate multiple keys. And that makes it quite hard, because the whole story about, well, let's skip this for the minute. It's a bit more complicated, but I'm almost out of time. So let me just end with an example of how I did this attack for a set of 5 cylinders that were given to me. What you can do is use the magnetometer, because in this case, the 5 cylinders, I did have no key at all, no keys. So I use the magnetometer to read out all the magnets. So that gives me a bit of information. I know that the middle 2 are the same for everywhere, and the bottom and lower one, they are different. And the only magnets that are the same for all cylinders, I've written down there on the top right. That is the magnet configuration for the master key. That will work on all 5 cylinders. And then I actually can also deduce what magnets will be in the individual keys, because they will differ from the master key wherever possible. Now for the pins, yeah, I have nothing to start with. I don't have a key to start with. But what I can do is I can use the bumping technique to open one, and I was lucky to have a half cylinder, because that can be bumped and can be opened and disassembled. So I actually opened it up, disassembled it, and looked at the pins. So I knew exactly what pin depths were in there. Now, I still don't know what the master key is, but there is only 2 times 2 times 2 times 1 is 8 possible master keys. So I just printed 8 keys. I tried them out on all the cylinders, and there was only one that worked on all of them. So that gave me the master key. So actually, I'm done. But I can also continue and use the trick I showed you before. For each pin in sequence, change the depths and try them out on all the keys. And with that, I can decode every bitting in every cylinder. And I know exactly what's inside of these locks. And I can also deduce what the individual user keys are, giving me all the keys and, of course, the master key in gold. Now, to summarize, because there's been a lot of information in a short time, so I hope you're still with me. But for the more visually, people who would like to see this visually, when you start, if you have a key, we can now duplicate the key using a 3D printer and inserting the magnets. That's an attack scenario. If you don't have the key, you can at least decode the magnets in the cylinder, and then to open it for the first time, you either need to try out 256 keys, do picking, but it's really hard, make a bump key that I showed you, that is possible. Then you have an opening, or impressioning, which I have no time to talk about. When you've opened the cylinder once, well, that might be your attack. Or if you are able, you could open the cylinder, look at the pins inside, which gives you information about what the real key looks like. Then you can print a working key. And if it is master keyed, then you can do this trick of going to different cylinders, gaining information along the way each time you do so, until eventually you have the master key and you are quite happy. So with the advent of 3D printers, key duplication attacks are becoming really easy to do. So that also means that your keys are like your passwords. You shouldn't show them in public, because people can just make an image of them and 3D print them. And for this key, you also need to duplicate the magnets, but you cannot deduce them from a picture of a key. But you could go to the cylinder, read them out, and then you again know exactly what key to make. Going from an individual key to the master key is still quite a bit of work. You need to do a lot of work, but it is possible. It is a feasible attack. I've done this with the help of Anker Slot themselves. The factory is in the Netherlands. I've been there before I made my presentation to let them know I was doing this. They knew about these kinds of attacks, so they were totally cool with that. So thanks to Anker Slot, and I would also like to thank you for spending half an hour with me. This is a link to the other talk I gave earlier, which includes more stuff about all the failures. If you like to hear about all the failures that have been done, that's where you can go. So I guess that's my time up. Thanks again for being here, and if there are any questions and if we have time.
Thank you. Thank you so much. This was fascinating, scary at the same time. We're going to go to 2 or 3 questions. One here in the front. Just a sec. In the meantime, if I may ask, like, what is the solution to this? Multiple locks on the same door? What do we do?
The solution, well, it all depends on your risk model. So what are you afraid of? If you are afraid of burglary, you need to do some other stuff than when you are afraid of somebody copying your key. If you're afraid that somebody copies your key, you might go to an electronic lock, electronic keys, or maybe include detection as well. The answer is it depends.
So thankfully we still have options, but it is getting pretty
Yeah, there are
unnerving. Okay, let's go to the first questions. Please stand up and ask your question. Who has the mic? Who has the mic? Okay.
You didn't talk about impressioning.
I haven't talked about impressioning. I tried impressioning, which is filing a key to fit the cylinder. I succeeded, but it was also harder than I expected. So I don't think it's a feasible attack to do it. It can be done, but it's really hard.
Hi. So my question is, what's the hardest lock you ever encountered and what made it so hard? If you can elaborate on that.
What's the hardest lock I encountered? Well, if you talk, well, yeah, depends on, again, what kind of attack. So if you talk about just lockpicking with lockpicking tools, yeah, there are locks like Abloy Protect that use rotating discs. That's really tough. But lockpicking is not really a real-world threat. If you have a lock that takes more than a minute to pick, then no burglar will try to pick your lock.
Makes sense. Thank you very much.
Okay, one more question. Well, okay, there we go.
Hi, sorry if I missed that. If you have a strong enough magnetic force, let's say neodymium magnet, could it like overpower the individual little magnets orientated in different positions?
The magnets, they are pulled back, to free the plug from rotating, but you can't pull them all the way through to the other side. They block. So this is really a binary on-off. If you have a magnet that pulls them the correct way, it opens, and you can't pull too far.
Yeah. And also, you cannot use a combing technique, I presume, because this way you lose contact with the magnets. So that's why you use the bumping technique.
Sorry, what technique?
A combing technique with a comb, like when you push the pins over
no,
the
you cannot comb, because then you need to have space on top of the keys, and there's really no space there.
Okay, sure.
Yep.
Thanks a lot.
Okay.